Hello guys, and welcome back once again to another video. Today we have this interesting algebraic equation right here, and we want to solve for the values of w, if not the value, right? Now before we start, if you're new on my channel, please go ahead and then smash the subscribe button, tap on the bell notification so that you'll be notified whenever I release a new video. Now without further ado, let's get right into it. Now take note, there are two possible ways of solving this problem, and I'm going to show you all the two methods, of course. But let's start with the shortest one first. The one that we can finish quickly. Let's do that first. So what I would like to do is that I would like to factor out the common terms, right? We have w squared, w cubed. We can take the w with the least power, right? And if we do that precisely, we are getting w squared out. Right here we have three w's. 2 is already out. So we are left with one of them. And this right here is what we have right there, right? So we are left with -1. And this is equal to 18. Now 18 is the part that is making the question super challenging, right? So here's the deal. I want two values that I can express all of them to have a power of 3 and then a power of 2. And it turns out that will be possible if I write it as 27 minus 9. First of all, I know that 27 minus 9 is giving me positive 18, right? However, I can write 27 as 3 cubed, then minus 9 could also be written as 3 squared. And if we compare what we have here to this one, it looks like they are literally the same, right? So you know the deal, right? Let's go. Now, this is going to be 3 cubed minus 3 squared. And that is it. So you all know that at this point, we can just go ahead and then tell the value of w. But of course, let's proceed further. So right here, just as I just factored out the one with the least power, I can also factor out the 3 with the least power, which is this right here. So that means we have w squared, w minus 1, and this is equal to, I just want to factor out this, and I'm left with, we have 2 of them is out, so we are left with just 1, then minus 1. What do you see now? It is super clear, right? If we compare the left-hand side to the right-hand side, you'll know that w is 3. Why? Because this -1 corresponds to this 3 corresponds to this one, this w corresponds to this. So at this moment, we can comfortably say w is 3. True of us. If you are still confused now, I'm going to have to put w is equal to 3, and this is one of the solutions. If you are still confused, don't worry, we can equate. This is equal to this is equal to this, and we are still getting 3. So if you don't want to do it this way, you can just say w minus 1 is equal to 3 minus 1. And if we add 1 on both sides like so, this will go, we are left with w, this and this will also go 3. So no matter what, we will end up getting 3, right? So that is pretty much it. However, because we have the highest power to be 3, maybe we have 3 solutions. So we have to go ahead and then look for the other 2 remaining. And that is why I don't prefer this method. And we have to move to method 2. Maybe that method will be able to give us all the values of w. That's it. All right, so for the second method, it looks like it's almost similar to the first one. However, we are going to do a lot of algebra. So what I will do is that I will keep the whole of this. This is w cubed minus w squared is equal to, just as we said, 18 could be written as 3 cubed, then minus 3 squared. And now I would like to equate everything to 0 by subtracting 3 to the power 3 and then adding 3 to the power 2 on both sides. And when we do that, this is what exactly is going to happen. We're going to be getting w cubed minus w squared, then we're going to be getting -3 cubed plus 3 squared. And at this moment, the whole of this is equal to 0. Pretty easy, y'all. Now, we are going to group all the terms with the power of 3 and then all the terms with the power of 2. And that will make sense because we can do a lot of things with that. So w cubed, then minus this right here, 3 cubed as one group like that. Then we have, now here you have to be super careful. We have w squared then plus 3 squared. This is equal to 0. Now for this one, we know something known as difference of 3 cubes, all right? However, over here you notice that we have addition of 2 squares. We don't have any identity for that, right? But if we are able to express this as difference of 2 squares, we can basically write its identity, right? So let's go. Now, how can I make that possible? I can make that possible if I factor out -1. And if I do that precisely, I'm going to have to keep this. And then I'm going to factor out -1, and I'm getting w squared minus 3 squared, like that. And this is equal to 0. And guess what? Now we have difference of 2 squares, so we can apply the identities. Now, before we proceed from here, we have difference of 2 cubes, difference of 2 squares. What are their identities, right? Remember this. If we have a cube minus b cube, its identity is going to be a minus b, and then times a squared plus ab plus b squared. Y'all remember this, right? Cool. And then if we have a squared minus b squared, which is the same as a plus b times a minus b. So these are the algebraic identities that we're going to be applying right here. So let's go. Now, the difference of 2 cubes. This is going to be w minus 3 multiplying, look at right there. It's going to be w squared plus 3w plus 9. This is what we are getting. Then over here we have minus, then difference of 2 squares, which will be w plus 3 times w minus 3. And this is equal to 0, right? This is precisely equal to 0. And now you notice that we have w minus 3, w minus 3. They are common, so we can just go ahead and then factor it out. As simple as that. So when we do it that way, we're going to be getting w minus 3 out. Then we are left with the whole of this and then this right here. So I'm going to put w squared plus 3w plus 9. Then you notice that this negative is affecting these two terms inside the parentheses. So we're going to have to distribute the negative like that. And if we distribute it, we're going to be getting negative w minus 3. Like that. And take note, this right here is what we have right here. So there's no problem for that. And this is 0. And from here, you notice that we can have w minus 3, then times, let's simplify the whole of this, right? So when we do that, we have w squared. Then this right here minus this will give us positive 2w. Then positive 9 minus 3 is giving us positive 6. And this is equal to 0. Isn't this beautiful, chap? Let's go. Now, product of 2 factors is equal to 0. We can have 2 possibilities. And the first possibility is going to be the first factor is equal to 0, or the second one is equal to 0. So we have this one right here is 0. So we're going to be getting w minus 3 is equal to 0, or this right here is 0. So w squared plus 2w plus 6 is also 0. Now, with this first equation, we have already identified that from the first method, right? So we know that this will be positive 3 if we add 3 on both sides. So w is equal to positive 3 as one of the solutions. We already know this one, so there's no anything serious about that. Then we move on to this equation right here, which is, let me keep it right here, w squared plus 2w plus 6 is equal to 0. Now, can we use factorization method for this so easily? I don't hope so. So maybe we have to use the quadratic formula. And because this quadratic equation is in terms of w, maybe I will just go ahead and then quote it this way. So w is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So we have to use this one to determine a, b, and c, and then we come back to it and then do the substitution, right? So here, I just have to compare this one with aw squared plus bw plus c. And if we compare it this way, you notice that the coefficient of the w squared is 1. So that means a is equal to 1. And then b is equal to the coefficient of the w right here, which is positive 2. And then c is this right here, which is positive 6. So we are going to be replacing all these values right there, right? So that means this is what we are going to be getting. Now let me clear this one real quick. So we're going to be getting w is equal to minus b, where b is positive 2. So 2, then plus or minus square root of b squared. B is 2, so 2 squared, then minus 4 times A, where A is positive 1, right? So we have positive 1 right here, and then C is positive 6, all divided by 2 times A, where A is 1. So we have this. Easy. Then we go. So W is equal to minus 2 plus or minus square root of, now let's do this real quick. We're going to be getting 2 squared, which is positive 4, minus 4 times 1 times 6. This right here is giving us negative 24. Negative 24 plus 4 is giving us negative 20, right? So we're going to be getting negative 20 right here, all divided by positive 2. And it looks like we are literally getting complex answers because square root of a negative number will give us a complex solution. So now the idea is there. So I think the easiest way to handle this situation is going to be something like this. We have W is equal to negative 2 plus or minus square root of negative 20 will be positive 20 times square root of negative 1, all divided by 2, right? And this right here is going to give me W is equal to negative 2 plus or minus. Now this right here is like positive 4 times 5 will give us positive 20, right? And square root of that. So this is what I mean. Square root of 20 is the same as square root of 4 times square root of 5. And this will give us 2 square roots of 5. So in place of this right here, I can put the whole of this, right? So this is going to be 2 square roots of 5, and then this will give us I. So I can put the I right here, but it's not looking nice. So maybe I have to get rid of it from here and then fix it over here, like that. Then all divided by 2. And now I think it is looking somehow good. So over here, we can just go ahead and then factor out the 2 because we have 2 here, and even on the denominator side, there is 2. So let's go ahead and then factor out 2. Then we are left with 1 plus or minus I square root of 5, all divided by 2. And you notice that this and this will go, and we are getting W is equal to 1 plus or minus I square root of 5. And of course, we have 2 answers for this one, the positive one and the negative one. So if we want to split them, then hopefully we are getting W is equal to 1. Taking the positive side, we have positive I square root of 5. So this is one of the solutions. And then W is equal to 1 minus I square root of 5. And that is pretty much it. So 3 answers, of course. The real part and the 2 complex part. Alright? So if you found the video useful, don't forget to smash the subscribe button, like this video, share to your friends, and I will see you again on the next one. Thanks for watching, as always. Bye.